Hello, I'm Harry Lee of Applicon, and this is the Design System Console, the focal point of our new automated drafting system. This is the display, a cathode ray storage tube that provides a flicker-free view of our drawings. The display is like a window over a large, imaginary drawing table. You direct the system by drawing symbols on the data tablet using this electronic stylus, or by typing commands on this keyboard. You can choose either method for controlling the system, but generally you'll want to direct as many functions as possible with the stylus, as this method enables you to keep your attention on the display at all times. Let me give you a few examples of how we can position the display window over the drawing table. This is a detail of a schematic diagram. Now if I want to see finer detail, I make this triangular command symbol around the area I want to see enlarged, press the stylus to execute the command, and the system erases the old view and replaces it with the new one. If I want to see still more detail, I can repeat the same command. Or I might choose this one, an inverted V, which will magnify the displayed drawing by an additional factor of 2. Now we've gotten in pretty close, and perhaps we need to take an overview. The command to fit the whole drawing inside the window is a Z, which quickly accomplishes our objective. Quite large and complex drawings fit comfortably on the Design Assistant drawing table. There are over 32,000 units of measurement along both the length and the width of the table. This means, for example, that working at a scale of 1/2 of a mil, you can easily accommodate an integrated circuit chip measuring 1.6 inches on an edge. Or at 1 mil, you could handle a printed circuit board measuring 32 inches on the side. Or at 1/16 of an inch, you could accommodate the floor plan of a building measuring 170 feet by 170 feet. As I mentioned, you can direct the system either from the stylus or from the keyboard. If you want to use the keyboard, you type in the command name and, if required, XY coordinate information. Any keyboard function can be transferred to the stylus through what is called the teach mode. On the right, you see a listing of the command abbreviations for some of the 150 commands that the system offers. On the left, you can draw a simple symbol of your own choice to represent a particular command. The computer tells me that C is undefined, so I can use it as the symbol for any of the commands in the dictionary, which is the name for this part of the database. Now, by making a dot over a particular command name, I teach the computer the association between that name and the command symbol. The command I associated with the letter C is called center the window, and it directs the system to reposition the window using my symbol as the new center point. Using the teach mode, operators can create their own dictionaries to suit their own particular needs. Once a dictionary has been created, it is available to all operators in the system and can be used over and over again. Applicon has a recommended set of symbols that many operators adopt as their own, making additions or changes to it as their needs dictate. You create drawings on the Design Assistant by assembling predefined graphic components and putting them together. Let me give you a few examples of what these components are like. Here's one basic component I use for this schematic. It's a symbol for a transistor. Here's another, a resistor. This schematic is composed of 7 different components, all relatively simple, which are defined in an area of the database called the library. By calling out these components from the library and interconnecting them, the whole drawing was created. The speed with which this can be done is perhaps the single most important reason why the Applicon system is the most cost-effective available. Before I show you how this drawing can be stored away for future use, let's make a reproduction of this hard copy unit, a device for providing inexpensive working documentation. The result is available within seconds. Now, to store this drawing file, we simply output the data onto a standard tape cassette by giving the appropriate command. The completed file will contain a dictionary, a library, and the drawing itself. In the future, if I need another library of the same components, all I have to do is reverse the process and read the file back in. Storing and loading is as simple as that. Now let's take a look at a different file. This one contains a printed circuit board schematic. Here's a check plot of the printed circuit board we'll be working with. The actual circuit required 1.5 hours to enter into the design system. By contrast, the same board would have required 3 man-days of effort to lay out by hand. Our file's been read in now. Let's take a look at the drawing. What you see in this close-up view is a composite of 8 levels. The design assistant makes available a total of 16 separate levels. The number used depends upon the drawing application, documentation needs, and your own working preferences. Here are a few of the levels in this drawing. On level 1, you see the board outline. On level 2, the component outlines. Level 3, the pads. Level 4, the same pads represented by circles. Level 5, the drill holes. Level 6, the component side metal. Level 7, the solder side metal. And level 8 contains all text. You determine the number of levels and how they're used. Sometimes the purpose is to separate drawing data so that it can be output separately for a manufacturing task. Sometimes it's to be able to work with the less complex and easier to handle drawing. As a further aid, levels can be made invisible so they don't show in the composite at all, or referenced so that they appear but can't be accidentally altered.